Hello viewers, you are welcome to today's topic on factorization. Now I'm going to review on the previous episode on factorization. One of my viewers said that the he did not understand the problem that I solved. Now I'm going to illustrate it further for him to understand, and other viewers that could not understand it will be able to understand it further. Now, when you are asked to factorize this equation, so like this, the reason why we use the discriminant, like the general equation which we call the almighty formula, is given by x is equals to minus b plus or minus b square minus 4ac over 2a. That's the general formula, what we call the almighty formula. And this b square minus 4ac is what we call the discriminant, is what we call the discriminant. You use it to test whether the equation will give you a perfect square. That is why we use this thing. It is not compulsory that you use it, but if you test it, if it give you a perfect square, it will. If you use it to test the equation, you can know whether it is a perfect. It will give you a perfect square or a rational number. A rational number like equation, like when we say like 3/5. They are called rational numbers. That's why we use it to test whether it will give you a perfect square. So when you want to use the discriminant now, we are going to use it to test whether this equation is a perfect square, so that we know whether it can be factorized, or you can use the almighty formula or the completing the square method to solve it. So now, why using the discriminant, we have b square minus 4ac, and you know the general equation for quadratic equation is ax square plus bx plus c. Ax square plus bx plus c equals to 0, where a here is 5, b here is minus 2, c here is minus 3. Now we are going to use the discriminant to test whether this equation will give you a perfect square, so that we know whether it can be factorized. Now, using it now, we have b here is minus 2 square minus 4 times a, which is 5, times minus 3. Now we have minus 2, if you square it to give you 4, minus time minus is plus, 4 times 5, 20, times 3, it give you 60, equals to 64. And the square root of 64 is 8. So it will give you a perfect square. So the equation can be factorized. That is why we test it to know whether it will give you a perfect square. That is why we use the discriminant. If you want to, you can. If you don't want to test it, you can go ahead to factorize. Now, the first step now, we are going to multiply this 5x square to 3. Multiply this 5x square to minus 3 constant, which will give you 5x square times minus 3 will give you minus 15x square. Now, the next step we are going to take now, we are going to find two numbers. This is a product, because 5x square times minus 3 give you 15 minus 15x square is called what we call the product. Then we're going to find two numbers. When you sum it together, that is when you sum it, it will give you minus 2x. When you sum it together, it will give you minus 2x. And when you multiply it together, it will give you minus 15x squared. That number is 5 times 3. 5 times 3 will give you 15. And 5 minus 3 will give you 2, which is this 2 here. Then, you know that this the coefficient of x is here is minus 2. So we are going to say, since 5 minus 3 will give you plus 2, we are going to minus, we are going to use negative. Now, minus 5 plus 3 is equals to minus 2. Minus 5 plus 3 is equals to, the equation we are going to use now is minus 5 plus 3, which can be said to be minus 5x plus 3x is equals to minus 2x, and minus 5x times 3x will give you minus 15x squared. You see now what I'm saying? Minus 15x squared. So we are going to use this. We are going to use these numbers algebra. Now we have 5x squared minus 5x plus 3x minus 3 is equals to 0. Using these numbers, we have 5x is common, x minus 1, plus 3 is common, x minus 1 is equals to 0. Then we have 5x plus 3 equals to 0, or x equals to 1. Now we divide both sides by 5. No. Since we have 5x plus 3 is equals to 0, 5x is equals to minus 3. We divide both sides by 5. We have x is equals to minus 3 over 5, or x equals to 1. Thank you very much.